Hey everyone, in this video we'll explore factorising monic trinomials as part 4 and we'll have a look at simplifying algebraic fractions. So over here I have x squared minus x minus 6 and on the denominator I have x plus 2. Now I will factorise the numerator firstly, so let me write down the numerator again. And now I'm going to factorise the numerator using the knowledge we gained in part 3. So two numbers when I multiply give me minus 6 and when I add give me minus 1. So let's have a look. Let's have a look at the factors of minus 6. I could have 2 times minus 3. I could have minus 2 times 3. I could have 1 times minus 6 and I could have minus 1 times positive 6. Now when I add these, 2 plus minus 3 gives me minus 1. I don't need to go through the rest of the list, so I know that these are my factors. So it's x plus 2 and x minus 3. So I'll rewrite the numerator. Instead of writing x squared minus x minus 6, I know that that equals to x plus 2 times x minus 3. So I'll write that down, x plus 2 and x minus 3. And on the denominator I have x plus 2. So if I have a number on both the numerator and the denominator, I could factorise them. I could simplify them. I could divide them through, and that gives me 1. So I am only left with x minus 3 over 1, and we know that that's x minus 3 on its own. So that is the factorised form of this algebraic expression. Alright, over here we have a more complicated version, but we will apply the same process. So we'll have a look at each of the numerators and denominators separately and then use the factorised form to simplify this algebraic fraction. So let's deal with x squared minus 9. So this is a difference of 2 square form. So this is what we had a look at in part 2. When I have a squared minus b squared, I could rewrite that as a plus b and a minus b. So over here I have x squared minus something squared that gives me 9, and that's 3 squared. So that is x plus 3 and x minus 3. So x squared minus 9 can be rewritten as x plus 3 and x minus 3. That's the first numerator. Let's have a look at the denominator. I have x squared minus 2x minus 15. Again, two numbers when I multiply give me 15 minus 15. So I could have 3 times minus 5. I could have minus 3 times 5. I could have 1 and minus 15, minus 1 and 15. And when I add these, I need to get minus 2. So 3 minus 5, well, that gives me minus 2. I don't need to go through the rest of the list. So I could write this down as x plus 3 and x minus 5. So x squared minus 2x minus 15 can be rewritten as x plus 3 and x minus 5. We'll have a look at the second fraction now. And the second fraction numerator was x squared minus 4x minus 15. Again, I'll have a look at the factors of, it was 5, not 15. I'll have a look at the factors of minus 5. So I have 1 times minus 5 and minus 1 times positive 5. They give me negative 5. Again, when I add these, the first one I end up with minus 4 and the second one I end up with 4. And I need minus 4. I'll stick with the first one. So I could write that as x plus 1 and x minus 5. So x squared minus 4x minus 5 can be rewritten as x plus 1, x minus 5. Alright, now let's have a look at the denominator of the second fraction. Now I have 2x minus 6. So I find the common factor, and the common factor is 2. So I could rewrite this as 2x minus 3. So 2x minus 6 can be rewritten as 2 on the outside and x minus 3. So what I now need to do is I need to use everything I have found. So use all the factorized forms and plug them in, so substitute them into my original expression, so into this original expression over here. So let's do that. So I had x squared minus 9, so I could rewrite that as x plus 3, x minus 3. And that was over x squared minus 2x minus 15, and I could rewrite that as x plus 3, x minus 5. And I also had times by x squared minus 4x minus 5, and that could be rewritten as x plus 1, x minus 5. And the denominator I had 2x minus 6, and that could be rewritten as 2 on the outside and x minus 3. Now my aim isn't to expand these fractions. My aim is to do as much cancellation as I can. So if I see the same factor, the same bracket, the same number, the numerator and the denominator, I could actually cancel them. So over here I have x plus 3 and x plus 3. Now that gives me 1 and 1. And I know 1 times anything will give me whatever the number there is. So 1 times x minus 3 is going to give me x minus 3. So over here, I move to the second fraction. I have x minus 5, and I have x minus 5 here, so I could cross these off. And I have x minus 3 in my first fraction, and on the denominator of x minus 3, I could cancel them out. You could only cancel out when you have the same number on the numerator and the denominator. So if I had the same digits both on the numerator, I cannot cancel them out. Or if they were both on the denominator, they have to be on opposite. So I'm left with 1 over 1 times by x plus 1 over 2 times 1. So, well, I know 1 over 1 is going to give me 1. So I have 1 times, no, x plus 1 times 1 is going to give me x plus 1. No, 2 times 1 is going to give me 2. Again, 1 times this fraction is just going to be x plus 1 over 2. Or alternatively, you could bring the fraction, the half, to the front and write x plus 1. So this is the factorized form of what we had over here, this algebraic expression.